Have you ever wondered what the moon's surface looks like? From here on Earth, it appears as a serene, glowing orb. But don't be fooled by its deceptive simplicity. The moon's surface is far more complex than what our eyes perceive from this distance. It's a mosaic of mountains, valleys, and plains, unlike anything we have on Earth. But don't be fooled by its deceptive simplicity. The moon's surface is far more complex than what our eyes perceive from this distance. It's not just a luminous sphere in our night sky, it's a world of its own, waiting to be explored. It's time to take a closer look at the moon's surface. The moon's surface isn't smooth like a marble, but rather it's covered in craters and mountains. Let's dive into the fascinating world of lunar topography. The moon's craters and mountains were born out of violent events, shaping its rugged landscape. The craters, those circular hollows that dot the moon's surface, were formed by the impact of meteoroids hitting the moon over billions of years. These meteoroids, traveling at incredible speeds, caused explosions upon impact, creating these craters. One of the most famous craters is Tycho, named after the Danish astronomer Tycho Brahe. It's one of the youngest large craters on the moon, estimated to be about 100 million years old. It's easily recognizable due to the star-shaped rays that extend out from it, caused by the ejected material during the meteoroid impact. Now let's shift our gaze to the moon's mountains. These towering formations were created through geological processes, similar to how mountains on Earth are formed. They occurred due to the moon's crust being compressed from impacts or through volcanic activity. The most prominent mountain range on the moon is the Apennine Mountains, stretching approximately 400 miles. The tallest peak, Mons Huygens, stands at a towering 5,500 feet, roughly comparable to some of the taller mountains in the Appalachian Range on Earth. The moon's surface is a testament to the countless meteoroids that have impacted it. These impacts have not only created craters, but also caused the moon's surface to be covered in a layer of loose, fragmented material known as regolith. This regolith, combined with the lack of atmosphere and weather, means that the moon's craters and mountains remain largely unchanged, frozen in time. So the next time you gaze up at the moon, remember that those spots and shadows you see aren't just random. They're the result of billions of years of cosmic events, each one leaving its mark on our nearest celestial neighbor. These craters and mountains give the moon its unique pockmarked appearance. But not all of the moon's surface is covered in craters and mountains. Some parts are flat, dark plains known as maria. Now, despite their watery name, which is Latin for seas, these lunar maria are anything but. They're actually vast, solidified pools of ancient basaltic lava, formed over 3 billion years ago when the moon was still volcanically active. These molten lava flows filled in low-lying areas on the moon's surface, eventually solidifying to create the flat plains we see today. Their dark hue comes from the iron-rich basalt rock that cooled and hardened over eons. The maria cover about 16% of the lunar surface, primarily on the side facing Earth. They're one of the reasons the moon's face appears to have man-in-the-moon features. So when you gaze up at the moon, remember, those aren't seas you're seeing, but the remnants of ancient volcanic activity. The maria add to the moon's distinct appearance, creating a contrast with the lighter, heavily cratered areas. So what have we learned about the moon's surface? Well, we've delved into its craters, mountains, and maria. Let's revisit those key points. The moon's surface is a celestial canvas, painted with numerous craters. These pockmarks are the scars of ancient impacts, a silent testament to the moon's violent past. They range from tiny pits to colossal basins, each one providing a window into our moon's history. Then we have the moon's mountains, towering peaks that can rival any terrestrial mountain range. These lunar highlands are the remnants of the moon's crust, pushed up by the same forces that formed the moon itself. They stand as rugged sentinels, untouched by the winds and rains that would erode them on Earth. Now, let's not forget about the moon's seas, or maria. These vast dark plains were once mistaken for bodies of water. They are, in fact, basaltic plains formed by ancient volcanic eruptions, lending the moon its distinctive two-tone appearance. One striking aspect of the moon's surface is its lack of atmosphere. This absence means no weather, no wind, and no water. And it's this absence that is responsible for preserving the moon's surface features so impeccably. The moon's surface may look distant and unreachable, but with each scientific discovery, we are getting closer to understanding our nearest celestial neighbor.